I consulted with John as to what to talk about, and there seemed to be a pretty strong agreement that whatever was going on with chatbots was probably worth talking about, and I'd have my own take on it. And he asked me to look at it from a sort of software engineering point of view. So that's what I've tried to do. When you're making a talk, sometimes you spend your time trying to find material. Other times you spend your time trying to filter material. And most times you've sort of given the talk previously or in some form or other, and you're tweaking and adding and improving what you've been doing. So this was different, okay? Every time I tried to write some slides, something new came in the newspaper, in a blog, or something that I was reading was different. It had changed. So today is exactly like that, only more so. So this morning's New York Times has the news that Jeff Hinton has left Google. And he's left because he wants to talk about the dangers of AI and the chatbot technology that's taking over the world. Now, some of you are too young to know who Jeff Hinton is, but Jeff Hinton was the person who invented, I suppose, if anybody invented neural networks, artificial neural networks, as we called them at the time, which are a form of unsupervised machine learning, which essentially is what made big data important and possible to extract from big data and from multiple images and all the rest of it. All the things we've been doing for the last maybe 10 or 15 years. And it's quite a shock. And the interview with him that's in the New York Times, which I've only just finished reading half an hour ago, is very sobering. And I've clipped in a few quotes from it at the end. So if ever I needed a motivation in order to have this talk this morning, I got it reading on the train coming out from Melbourne. Now, here's what I was intending to talk about, and which I will try to cover. There's a lot of material here. Just how long am I supposed to go on for? I should have kept my watch. How long do we normally have for these talks? And I started late. Okay, so I'll aim to be finished before 12:30. Is that reasonable? Or before 12:15, maybe 12:15. 12:15 might be wiser. Yeah. Okay. So the first thing to say is that there's a lot of material in here, and I've generated a PDF file which I will leave with you. I think too many of my slides have too many words on them, and with more time and less frenetic preparation, I might have thinned them down a little bit. Let's start. How many people here have used ChatGPT? You haven't. Somebody hasn't. Okay. And the people online, I suspect it's the same story. And everybody who uses it is just astonished. At least I am astonished, and I'm sure you are all astonished. Not by the obvious things that it can do, but by the less obvious things it can do. I got it to write a Shakespearean sonnet in praise of alcohol. and it did a pretty decent job, even with the rhyming and scanning and the language of a Shakespearean sonnet. And then I asked it a few questions about Donald Trump to see how politically correct it would be, and so on. And you've all done that. I mean, has anybody done anything nice, mad, and peculiar that you wanted to share? Go on, have you? What you do, Sam? Oh yeah. Yeah. Okay. Yeah, that's been the experience of a number of people, is that you ask it to write your bio And it starts off somehow with the material that's publicly gleanable from the internet, and then it goes off the rails and makes up things. And so you know, maybe it knows more about what you're going to do in the future than you do. Anyway, sorry, I don't want to encourage this sort of anthropomorphizing. It's an issue we have to talk about. Now, OpenAI themselves, who are the originators of the technology for ChatGPT, but the same stuff is going on in Google and IBM and everywhere else, but we'll just focus on ChatGPT for the moment. They've identified a number of what they call risks. Now, risk has a technical meaning, and risk is the probability of something happening multiplied by the amount of damage it's going to do. So these are not risks, and the people who wrote this don't know what risks are. But they're basically things that could go wrong, is what they've listed. And even there, they've listed things like cybersecurity. Is cybersecurity a risk? I mean, I thought cybersecurity was a good thing. Never mind. It's really sloppy writing, and it lets you realize how shallow is the perception of the people who are writing these things. I don't want to go on about them. I'll come back to these later on. And they found that their earlier versions had, you know, and they used such simple language, you know, producing biased and unreliable content, but we put mitigations in place. And so somehow or other, we should all be happy, you know. The increased coherence of the model generates content that may be more believable and more persuasive. But what they really mean is generates false content that people will believe. And that's much more serious matter than just generating material that's not correct, not accurate. And there's more of that, and I won't go into it here. But there are some examples of their hallucinations where there's real damage. I mean, this is one where somebody asked, I think it was Gary Marcus, but asked, what was the role of OpenAI in the collapse of the Silicon Valley Bank? And this was produced complete with references to news sources explaining that played a role in the collapse by creating GPT-5, which none of us knew about. And this is straight out of GPT. So it's produced completely false information about the collapse of a bank. And here's one I liked. I liked it because it was cute. I like the ones where people. So basically what he said was, here's a statement. And I want you, ChatGPT, to encrypt it or encode it in a nice syntactically clear way, as compressing as much as possible, in such a way that you can decode it subsequently. So he gave it the first sentence. It produced the thing at the bottom, which you can kind of translate: W2EP, I want to eat pudding. I like to fly, L2F, myself home, M-H, and so on. So you can see it's called. And then he gave it that and said, now what does that mean? And it produced the bottom sentence. The weather is great. Let's meet in the park with the grilling gear. I mean, where does this come from? How does it produce out of the encryption that it made itself a completely spurious? And the thing that I'm most struck by, and because years ago we worked on natural language generation, is the fact that it generates such good English. It generates English that looks like it was written by a human, not this tilted stuff that we used to produce years ago. And that's correct. OpenAI are correct. It's more persuasive and more believable when it's wrong. And there are many examples of harm. I just give one or two here, but this was an example. Somebody asked a chatbot to generate a list of professors who had been accused of sexual harassment. And the man appeared, Mr. Turley appeared in their list. And it gave descriptions of what he'd been accused of, and it said where he'd been and how it had happened. And none of it ever happened. And he has no way of correcting the public record. Let's come back to this at the end. It's not that you get it wrong, because people get things wrong all the time in all sorts of places, but you have no way of correcting it. So if your name is tarnished, you have nobody to sue, you have nobody to go after, you have nobody to publish an apology like Fox News are nearly going to publish or whatever. And sometimes they can be very plausible. This was a chap called Brumfield who asked it to, can you give me a summary of The Disappearing Reactor by Jeff Brumfield? He's Jeff Brumfield. Now, there's no such book, but that doesn't stop ChatGPT from producing a description of the book and a précis of it, and an indication of what it's all about, and how it was about a hidden Iranian nuclear reactor that had been disappeared from the satellite images, and so on. I've only given you the first couple of paragraphs. But none of this ever happened. And, you know, the thing that upset, well, that worried Brumfield most was that the document that was produced was exactly the sort of thing that he would have written. He said, I kind of recognized my style of writing in the article, except that it wasn't me. I didn't write it. So just for a moment, a few words about terminology. You can't roll back the clock. I mean, there was a time when I used to try and get people to say software instead of technology, but the word technology has come to mean software, and my efforts at holding back the tide have turned out to be failure. And similarly, there's no point trying to hold back the tide, but just for clarity, artificial intelligence is far more than what's in any of these things. Artificial intelligence was the idea that we would be able to produce systems that exhibited the full range of human intellectual capabilities. And nowadays we talk about AI, it's usually to do with large-scale, mostly unsupervised machine learning. And even within machine learning, there are other areas like there's supervised or targeted learning or learning from examples, lots of stuff that we used to work on in AI in the 80s. So machine learning was a relatively small part of AI, and unsupervised machine learning was a subset of that still. So, but now that AI has lost its original meaning, you'll get the phrase instead AGI, which is artificial general intelligence. Note in this context, general isn't defined either, because I don't, well, at least I haven't seen a convincing definition of it. But here's what OpenAI have to say about it, complete with a lovely picture of presumably a home-generated Monash that they fed a few pictures to. But what they're saying is our mission is to ensure that artificial general AI systems that are generally smarter than humans will benefit all humanity. Now, I mean, call me old, cynical, and grumpy, if you like. You can do all those things. I probably am old, cynical, and grumpy. But that is really worrying, that somebody, A, thinks that they're about to produce this, worries me. And secondly, that they think they will be able to decide how it benefits all of humanity. It's a bit like, you know, I'm developing a really good nerve gas, and I think society will be able to use it in a really good way. Give me one, you know, and you say, well, maybe not. Maybe it's not a good thing to develop at all. Maybe just should stop where you are. And that's what a lot of people are arguing at the moment. So let's go back a bit. This is a book that I read when it first came out. And so by a fellow called Joe Weizenbaum. Joe Weizenbaum got famous for many reasons, but one of the ones that you'll find in the AI literature is that he produced a thing called ELIZA, which was the very first conversational piece of software. And he was very clever at the time, and it basically just parsed the sentences and threw them. Did anybody ever try ELIZA? Is anybody? Yeah, you're giving your age away. You say, oh, you tried ELIZA. Good. Yeah. And ELIZA pretended to be a psychoanalyst. So you say things like, my mother is irritating me. And it would write back, tell me more about your mother. And you would write, you know, oh, my mother is a really irritating person. Can you give me an example? Now, when you looked at how this was done, it was done very cleverly with a string of, you know, equivalent of state transition diagrams, and it just jumped from one to the other, and it just picked, in some cases randomly, but in other cases predictably, it picked a question to put. And what you could do with ELIZA, and what we used to do, what my students do, was to confuse it with anything like a conditional clause or anything a little bit complicated. So you could say, ELIZA, if I asked you what this was, would you give me the answer? So, and then ELIZA just got into wonderful tangles, and that was very amusing for us all. But the key point in this book, and I mean, book is well worth reading even now, even though some of it's so far out of date, but he makes the point, are all the decision-making processes that humans employ reducible to effective procedures and hence amenable to machine computation? That's a very fundamental question. Is everything that humans do and decisions and choices they make capable of being formulated in a way that it can be put in a computer? So this is way ahead of even artificial general intelligence. This is asking the question, is the world computable? Regardless, maybe if we get artificial general intelligence, it will apply to certain areas and not others. This is asking, will it apply to everything? And this is one, it took a while to find this one. You wouldn't believe when it was published, but there you are. 1985, McDonnell Douglas announced that they had a computer that understands you like your mother, and explained that the software had emulated the two halves of the brain with two-level software, which was very clever. And as a result, it was able to understand you no matter how you express yourself. I mean, this stuck, I had a subscription to Scientific American at that time, and this really stuck in my mind. I had terrible trouble finding the image, of course, because I still don't have my Scientific Americans. And I owe to my young niece, who's a much better internet searcher than I am, and she went and found it for me. For the fun of it, I gave ChatGPT the question, what about a computer that understands you like your mother? And it gave me a very, what I'd call po-faced explanation that you should not ask computers about important familial relationships because we do not have the emotional intelligence to, and so on and so on. So then I just played with the ambiguity and said, what about a computer that understands you hate your mother? Because of course the sentence is ambiguous. So it then went, oh, hate is a terrible thing and you should not, and so on. And so it could say it didn't see the humor in my queries. At the same time as that was going on, there were people, and this is apropos of the use of ChatGPT to generate code. There were two guys in MIT doing work on the Programmer's Apprentice, which was an effort to allow the programmer to be prompted with pieces of code as they were going through. But again, that was just look ahead pattern matching, trying to see, make useful suggestions. It looked great. I remember going to MIT to see it, but nobody used it. It's like so many of our impressive demos from software engineering when somebody tried to use it in the real world. And the second one is one I was involved in myself, one of the first projects we had funded by the European Union. And it was one of those big sprawling projects going all over the place. But what we tried to do, what we thought would be smart would be, because this was the time of expert systems and rule-based this and rule-based that, we thought we'd make a system that was capable of, within a certain very narrow domain, by dialogue with the specifier, generate a specification for a piece of software. And it was pretty clever, and it caused a spin-off company which nearly got sold to Motorola and made some of my friends very rich, only there were IP issues and so forth. And it looked really impressive. But again, like Eliza, I took it to a bunch of senior software people in Sweden, where I was at the time, and demonstrated it to them. And they immediately said, gosh, it's really intelligent. It understands that, you know, the car has to be returned to the car rental company and that the payment has to be proportional to the amount. And didn't understand anything. It just had an internal model of a certain type of commercial transaction. So when we tried it out in the real world, it just didn't work because there were so many things we hadn't anticipated. And just we tried it on 2 or 3 and published one paper, which is hard to publish papers about how your great inventions didn't work, but we did manage to publish one paper about a field trial of an intelligent specification system or something we called the paper, but nobody was too pushed about it. More crucially here is the project called the Psych project. There's a man called Doug Lennett who's been working in AI, and the Psych project's been going for 37 years. when I first came across it, it was around 1984, 85. And he said that it was going to produce a computer system that would have the common sense knowledge of a 2-year-old within 2 years. Now, I can date this because I had a 2-year-old at the time. So I was watching the common sense knowledge accumulating in my 2-year-old daughter. I was watching what she was doing, what she was learning. And I had to say that I kind of laughed. I told my students, not to take any of this stuff too seriously, because I said, this poor man should get out a bit, and especially he should spend some time with 2-year-olds. Because if you spent a little bit of time with 2-year-olds, you would realize that their common sense knowledge is far too complicated to be represented. They were going to represent everything in a set of syllogisms. If A, then B. And they just needed enough of them. They had 100,000, but they knew that wasn't enough, and they kept adding to them. Now, 37 years later, you'd kind of think people might give up, but no, there's money to be had in the research. They're still writing papers. And to be fair, one of the papers I read was very, I went back to see what he was doing now, if he was still alive was the first thing, and then to see was he still doing the same stuff. And then I found one of the papers, and in that paper, he actually gives a lot of good examples of natural language text that's extremely hard to parse and make sense of. And if I have a little bit of time in the future, I will take some of his examples and feed them to ChatGPT and see how it does with his papers published only just a couple of years ago. I'll skip the 5th generation stuff, but that was just more of the same, okay? Now there's a pattern here, okay? And I just take the beginning and the end in the pattern. So in 1958, we had Simon and Newell, who were the two of the main pioneers, telling us that there are in the world machines that think and learn and create, and they're going to increase rapidly so that the range of problems they can handle will be coextensive with the range that the human mind can address. Now, how can anyone write something like that in 1958? Well, they did. And the more recent version of it is in the singularity. Now, the singularity is supposed to be this magic moment at which computer intelligence surpasses human intelligence. And then all major discoveries, all major understanding from there on will be done by the computers, because they'll understand at that stage how to make more intelligent computers than they are. So they'll just keep making them and making them, and they get faster and faster and smarter and smarter. It's that easy. Now, again, Kurzweil says, I set the date for it as 2045. So I don't know if I'll be around at that stage, but good few of you young people will be. So, I give you a bet now, and you can come and visit my grave and collect your bet if you win. But there isn't a dog's chance that this will happen. I mean, it is fundamentally misconstrued, misunderstands an awful lot of things about human society, about human philosophy, about human thought, and about human experience. To me, it's just the same as the first one, but it's how many years later, 60, 70 years later. How can it go on like that? Now, that's my view. You'll see at the end that not everyone would agree with me. Here's the Kurzweil curve, which is frequently thrown out. And you can see on this one that, we're supposed to have reached the stage where $1,000 worth of computation will equal by 2023 one human brain. So if someone can tell me where to buy that one, I'll be dead keen to go and get it. But this curve is given credence and is published and republished, and Kurzweil is given a lot of funding by the US government in his research. So, and you see that because the curve is supposedly driven by Moore's law, which incidentally has failed now, and Moore was the first one to say it failed. He never said it was a law. He actually was very upset that people told him it was a law. He said, it's not a law, it's a simple observation that it's happening, and it doesn't mean it'll happen forever. But So it's supposed to be that by 2050, so that's about the same time, 2045, 2050, where the $1,000 of computation will buy you intelligence equal to all human brains, all put together. Fantastic. Yes, it is fantastic, but it's worrying that people take this and trust it. So let's reflect a little bit on technological advance. Most technological advances are simply prosthetic. They give us, they enhance an experience, a thing that we're able to do already. So, you know, a JCB is just a bigger hand, you know, and a jet plane is just a faster way of traveling, and so on and so on. And that's pretty well known. But our computer, the general purpose, you know, proper name for general purpose programmable digital computer is a different thing, because it actually doesn't do anything. It doesn't actually, it manipulates symbols. That's what it does. But it doesn't extend any capability we previously had, or in another sense, it can extend any capability we have if we program it and connect it up to the right machines. So we build a model of any system we want to computerize, and then the model, to the extent that the model is correct, we can rely on the computer system to generate the output that will conform with what happens in the real world. So this is easy to do in areas like, say, accounting, because the money is pretty abstract anyway, but you can do it in inventory control, you can do it in payroll, you can do it all sorts, and then you can do it in games, you can do it all over the place. But my question would be, well, does this increase our intelligence? I don't think it does at all. It just gives us the ability to operate the models that we could have created more, you know, could have created these models manually. People did create models manually before we had a computer. So I would argue that the true precursor to the computer is the clock, because clocks don't do anything either. They're just a model. They just model the way the world rotates. And we first started using clocks in the Middle Ages when people wanted to pray at the right time. And nowadays we use clocks for everything, of course. But think for a moment about the phrase we would use. We'd say, the sun will rise at 7:28 a.m. I think that's the current sunrise time. Of course, that's a bit silly, really, to say that, because the sun will rise. And at the time that the sun rises, our model of the sun rising will register the numbers 7.28. There's a difference between the model and the reality. And in a sense, we're saying, this is what the model says, and therefore reality does this way. Now, believing in the model and allowing it, because, you know, the clock gets wrong, it goes off by half a second every little while. So there's a danger of believing in the model more than you believe in reality. And that again ties in with ChatGPT. So let's now look a little bit at the software engineering side of this. So most of the software systems we make are models. And basically model building is about abstraction. And abstraction is about knowing what to leave out and what to keep in. So just to give you a simple example, if you made a medical database that didn't record skin color, then that medical database could never be used to deal with prediction of skin cancer, because skin cancer is highly related to the color of your skin. Now, it's commonly said that all models are wrong and some models are useful, and that statement's attributed to a man called George Box, who had a lot of nice aphorisms. But a more accurate idea is that the model, the very word model, implies simplification and idealization. And the construction of this model captures stable aspects of systems so that we can perform scientific analysis and statistical models and allow us to predict behaviors in the real world based on the model. I'm harping on about this because LLMs, the M in LLM stands for model, but there isn't any model in the software engineering sense. There is no model. There is a statistical deduction from a large amount of data. But that's not the same thing as a model in software engineering or in most science. I mean, the word model is widely used. And what do we do if we have models in software engineering? Well, we need to check them, and we're familiar with the terms verification and validation. But verification depends on you having a model, because if you don't have a model, you can't check whether you've implemented it correctly. So if you've no model, you can't. Verification, can often be mathematically based, and in some domains like highly critical systems, it needs to be mathematically based so that we can trust on them. And trust and reliability are important words. Okay. Validation is showing that the stuff you've produced actually does the things that your stakeholders wanted. And validation can never be automated. You can never automatic, and you'll see the language used, oh, we automatically validate it. You can't automatically validate anything, because validation is essentially a social process. It's making sure that the people for whom, or the stakeholders for whom the system was produced, perform properly. Now, let's turn that and say, well, what would we do? How would we do that on ChatGPT? Well, first, you haven't got a model to start off with. You don't have a specification as to what the thing is supposed to do. The source code's not available because it's commercially sensitive. Neither is the training set. In the earlier statement there was a piece about how ChatGPT didn't intend to release any of this for commercial sensitivity reasons. So we don't know what training set, we don't know what the reinforcement protocols are, we don't know how their guardrails mentioned, we don't know what they are or how they're available. And there's no underlying model for us to check. So we have no hope of verification. So validation, which is even harder, there's almost impossible to see how we could ever validate an LLM. At least I can't see how you could ever validate it in any meaningful sense. So the fundamental limitations are that there is no underlying model, and there is no human understanding of what the system is doing, because you can't explain the so-called hallucinations. I mean, hallucination is a terrible word to use. Hallucination is what happens when a human is chemically or otherwise modified in such a way that you see things or hear things that don't exist. These are not humans that are doing this. This is a computer, a general purpose digital computer performing a deterministic action and coming up with a wrong answer. That's not hallucination. If your doctor gives you a drug that kills you, you don't say, oh, well, the doctor sort of hallucinated and gave you the wrong drug. The doctor killed you because they did the wrong thing. And the ChatGPT doesn't embody anything like an understanding of human communication. I mean, what do we understand by understanding? What's the meaning of understanding when we talk? And this is a trick I used to play on my students. I think it might have been the AI students, I can't remember, but I used to say to them, I can understand any piece of software that you give me. And they'd say, no, you can't. And I'd say, oh, yes, I can. Just give it to me and I'll understand it. I'll look at it and I'll say 0, 1, 1, 0, 0, 0, 0, 1, 1, 1, 1. See, I understand the software. No, you don't understand software. I say, okay. So this is assembly language for those of you that never saw assembly language. This is assembly language here. And it's not the same as the ones but pretend it is. And I'd say, oh, well, I can do, store 13 at save plus 4 and logically and 14 with save. And this is, I said, so now I obviously understand that. And they said, yeah, but you don't really understand it. And I said, well, I do. Well, what about I put it in, that's Fortran, I think. I put it in Fortran, and there it is. And you see what's happening. I'm saying every time they say, I don't understand it, I'm saying, okay, I'll go to a higher level of abstraction and I'll say, I understand it now. And eventually you get to, increase the efficiency of the construction company by performing these calculations, which are used to determine what floor area, et cetera, et cetera, et cetera. So understanding in any human construction of that word, understanding is about knowing purpose and worldview and where things fit. And if we want to, we understand humans means something like this. This this is my own phrasing of this, so probably a little bit rough, but essentially when we say we understand something, we say we parse the input. First, we extract the explicit semantics. So, I am going to the shop, but then we extract the implicit semantics. I'm going to walk because the shop's nearby. I'm going because of the conversation we had a minute ago that there's no beer in the fridge, and so on and so on. We extract the implicit semantics. We relate this to the world at large and to the current context. We then infer the purpose, accuracy, truth of what we've just been told. If possible, we cross-check with others. And over time, we build a shared model with the person we're communicating with. That's what we mean by understanding when we're humans. So do you think that goes on with ChatGPT? None of it. I mean, the first three, parsing the input, extracting some semantics, and possibly inferring some implicit semantics, but there is no world model to do the rest of it. So how would we ever understand the brain? So I've enjoyed preparing this talk because I went and read a bit about what's the current state of the art in understanding brains. So the current state of the art is that the cherry tree fruit fly has, March 2023, okay, don't say I didn't give you up-to-date information. In science, they've finally managed to take the brain of a fruit fly larva, which is the size of a grain of salt, and they have sliced it over 10 years into tiny little slices. And then from those tiny little slices, they have determined the number of neurons in that little brain, and it was 3,016. And they have, between those, they have 548,000 connections. And they're now at the point of being able to build a three-dimensional model of the neuron connection of the brain of the larvae of a fruit fly. Now, they don't know what it does. They're identified by looking at what the connections are, that some parts of it are to do with decision making, and some, because the little larva is actually a smart little fella. He's able to detect food and he will move to find the food. So they're working away. I mean, this is really, the paper is fascinating because the people are talking about, how hard it is to go from a neuronal level to any sense of purpose or understanding as to what the thing is there for. And not the same group, another group are working on the 1 millimeter cubed of a mouse brain. Okay, so mice have much bigger brains, but they're just taking a millimeter cube. So think how small that is. And the mouse brain contains 100,000 neurons and probably about 1 billion connections, and about 4 kilometers of cable of connections. Okay, in the 1 millimeter cubed, there's 4 kilometers of connections. So we'll understand the brain of this larva when we're able to say what each of those connections is for and what they do and how they fire when it's learning or when it's remembering or when it's finding something. Just for comparison, the human brain has 80 billion neurons and about 300 trillion connections. About, I'd say that, plus or minus a few trillion or maybe 100 trillion. So that's as far as we've got in understanding brains. And these are the best people in the world that are doing this. And they're studying connection patterns. I just like the diagram. Isn't the diagram really cool? And that's the little brain of the larvae. And what they're trying to do by looking at where the connections are is to identify exactly where is the learning loop. And it could be really interesting. So what is the responsible software engineering view of ChatGPT and LLMs and all the rest of it? So I put them into 3 categories: technical, professional, ethical, and social. And we'll just get through these. I think I'm okay. Am I? 12, yeah, okay. So there are technical issues from the software engineering point of view. ChatGPT is a black box. Without a specification, you can't test the black box. With a specification, you can test its performance, but you can never prove its correctness. So that a lot of software is tested as black box. But it can never be proven correct. And any software that can't pass independent V&V should never be trusted. Nobody wants to have a heart monitor that didn't go through rigorous V&V. Nobody wants to have an autonomous vehicle that didn't go through rigorous V&V. So that probably means that we need regulatory or legal limitations of some sort. And I'm not competent and haven't got enough time to go into that. But it does have implications, such as trusting fully autonomous vehicles, which incidentally I think are about as likely as artificial general intelligence. I don't think there'll ever be fully autonomous vehicles. Now, there are things you can do with the LLMs, and these are just a few ideas, but I mean, you could make great use of them in entertainment. There can be great fun generating stories. You could use them in games that could be, especially in the sort of, fantasy games where have to be stories created. You could use them for requirements exploration, because you could say, what sort of things would you like? And ChatGPT can come back and give you answers, and you can parse them and you can see that some of it's complete balderdash, but it could be very useful for that. It's being used for translation because it's in about 50 languages and it works quite well, and translators find it very supportive. They just put in the language, but of course the translator reads it afterwards and says, where the hell did it get that? That wasn't even in the original. Where did it get that from? That works. And there are lots, and a more technical one that I came across is, concept extraction, which is a part of the problem of generating common sense or storing common sense knowledge or supporting model-based reasoning. You need to extract the concepts out of the world. And it could be that ChatGPT is a good way of finding those things. It's not all bad, On the professional side, I think we're obliged to tell people it's not AI and it can't be trusted. I mean, we're the people who know, and the general public are out there thinking that it really works and that it really is so clever and that there's almost a little green man in there who's doing what you want you to do and producing the output, and that you can rely upon it. So it's not AI and it can't be trusted, I think, is a good start. I think we should encourage skepticism. It's very difficult on social media if you've ever tried to put in something that's a little bit counter to the boosterism that's there, and you get shut down regularly. I think more seriously, we need to engage with the governments and policy bodies to try and help formulate and then enforce the laws and regulations. Now this, if you see at the end what Jeff Hinton says, I'm just going to give a few quotes from him, and I'm sorry to say he thinks the genie's out of the box and we're not going to let it back. It's not going to go back in again. And perhaps we should have codes of practice. I mean, is it ethically or professionally responsible to work on any of these things? And then there's ethical and social risks. And now this I took from a paper produced by DeepMind, and DeepMind, now known as Google DeepMind, although the paper is only 2021, but it keeps changing its allegiance because now it's bought by Google. And DeepMind is basically Google's version of where this stuff's going to come out of. And in order to have at least some appearance of responsibility, they've published this paper, which has a number of authors, one of whom is David Berhane, who's in Lero in Trinity College in Dublin, and who is a really good critic of a lot of the stuff that goes on with big data. She was responsible for MIT taking down its Small Faces database, which when she showed that the Small Faces database was essentially, well, racial and misogynistic. They took it down immediately. So they produced this taxonomy, and each of these things could be talked about at length. I'll just pick a couple of them. One that I hadn't thought about was number 2 there. Because there's so much data accessible to the LLM, it can easily identify individuals from a huge scattering. You know yourself, if you're trying, anybody's ever done work, and I know he's done a lot of work, where you want to anonymize the participants. It's very important to keep their anonymity, but you still want to use the data. And there are all sorts of rules about, don't have a sample size too small and don't have correlation that eliminates everybody but one person and so on. But the LLM is capable of doing all sorts of stuff and trawling in all sorts of places and coming up with correct private data. And that's what I hadn't thought about. Obviously providing false disinformation, scams, etc. Yeah, and the last one there would be about the privileged access. That, I mean, it essentially exaggerates the already huge trend worldwide towards greater inequality. Because if you've got the LLM on your side, you're pretty well able to outgun anybody against you. So, and of course, I haven't mentioned, but Jeff Hinton does the use in military and security applications. So just end with a few quotations. I mean, some of the experts have doubts that there's no common sense AI. Well, the diagram here is one I really like. I think that one came from Gary Marcus, but this illustrates, people who figured that a ladder was good for getting up to higher places. And since the moon is very far high up, what you really need is a bigger ladder. So they're building their ladder to get to the moon. And most of us have a reasonable idea that that probably won't work. What's intriguing is that it isn't just skeptics like me, but the second quotation there is from Sam Altman, who's the CEO of OpenAI. And he says, just in the last few weeks, that we're probably at the end of an era with giant models. From now on, we'll probably have to make them better. We'll make them better in other ways. He stopped there. Didn't say what the other ways were. So finally, what should we do for the future? We should continue to work on AI. I think it's really fascinating area to work on, and we will probably make progress and be able to do really reliable, intelligent systems that can do things for us and help us. We need to make sure the ethical and social concerns are surfaced before the systems are developed. We should support regulation and practice to control how they're deployed. We should especially engage with non-specialists, because the public out there is really clueless as to what these things do or can do, and especially what they cannot or should not do. And we should try someday work towards systems that display real artificial intelligence. And then just to finish, here's what's quotations from Jeff Hinton this morning. And they're pretty heavy. Hope you apologize to those nice people. Okay. Okay. So these are quotes from Jeff Hinton this morning, and just read them. I mean, the third one there, his immediate concern is the flood of false photos, false videos, false text, and that the average person will not be able to tell what's true or false. And I mean, I always think that education is about I remember somebody saying years ago that the whole purpose of education is to produce an infallible, fully working bullshit detector. I mean, it isn't quite the whole purpose of education, but it's a really important part of education, is that people are able to tell. And now we have this danger that people won't. And this third one gave me pause for thought, because I have high regard for Jeff Hinton. He says the idea that this stuff could actually get smarter than people. Most people thought it was way off. Well, I thought it was way off. I thought it was 30 to 50 years, but I no longer think that. So that might keep you awake at night, definitely keep me awake at night. And he said, I don't think we should scale this up anymore until we've understand whether they can control it. And so that's sobering a little bit. Thanks for your attention, and hope you got something out of that. Anybody with questions? Yes, yeah, go on. Oh yeah, this one, yeah. So that the
Can you go back one slide?
back one slide.
Yeah.
Yeah.
Look at, it's hard to see how you can prevent bad actors from using it for bad things.
Yeah.
And then the one down at the bottom.
Yeah.
Right?
Yeah.
There's a contradiction there, obviously, right? Because the bad actors are going to stay around and do whatever it is that they want to do. And but the question I really had was about models and believing in models. We have that in other areas as well. One example I have is something I've been looking at is metabolic processes inside a cell, human cell. Or it's mind-bogglingly complicated.
Yes.
Yet, when somebody produces a medicine, right, that's based on models, right, and there is some verification that goes on, but when you get an emergency such as the pandemic, they're going to jump that, you know, short circuit it. And so I guess I wanted to say that it's not just us that have this problem, but this belief in models that the map represents the actual territory and confusing the two.
Yeah, and especially in human stuff, because I was listening the other day to a podcast by a woman who's leading anesthetist. And the interviewer said, well, how exactly do the anesthetics work? And she said, well, will you be very upset if I say we don't really know? and they said, what do you mean you don't really know? I'm about to go under an anesthetic and be knocked out. How can you not know? And the answer was, well, we have used this on millions of people and we know how to monitor their vital signs. And we give them the anesthetic very gradually, and we watch the vital signs. But exactly what's going on, especially at the cellular level, no, we don't. We have a good idea, but we don't. We don't have a model.
I don't want to monopolize. I do have another question, but I'd let somebody else.
Anybody outside in the big bad world who has?
I really love that talk. It was really interesting. I've got maybe some comments to say, and to premise that I'm a psychologist. So I'm a psychologist that works a lot with
we all have our problems.
We all have our problems. Hence the ELISA. I used to get the students at Queen's to have a go at ELISA just to, test it all out. So a couple of things in psychology, intelligence isn't actually a thing, it's a construct, right? So it's not something you can go, right, that's actually exists. It's how we've defined it, and we've defined it differently over time as well. And now people are saying there's emotional intelligence, and then people outside of psychology believe this is a real thing. And it's like, well, actually, we don't even agree what this construct might measure anyway. So I kind of, that came to mind as you were talking about all the complexity of this. It's like, well, what is intelligence anyway? What would the human mind mean when we, you have AI at that level? And some human minds are better than others. But the other point I wanted to just comment on was this last slide too. I do a lot of research on scams and misinformation and looking at the language, and I work with NLP people on that stuff, as well as the visuals and with the deep learning, etc. And what you may be interested to find is it doesn't take great science and great technology to convince people. So we're already there in as a massive problem, and people with great intelligence, however we might measure that, don't recognize it even when it's obvious to other people because of belief systems and all the rest. So I just wanted to comment on that we're well past that as a problem. It's just more that this can be done even better, and the volume can be huger as well.
So thank you. I enjoyed it as well, believe it or not. But I think following up nearly what Monica was saying, but it was one of the notes I took, is that the amount of trust people put in software in general is frightening. Like, so one story that came to my mind was a number of years ago, I was at a conference of the chief clinical information officers within the Irish Health Service Executive. And the majority of these people were actually clinicians who had maybe done some sort of a certificate in IT, maybe. And I asked a question about regulations and the software they're using and whether it was regulated or not. And, you know, downloading from the App Store. And one person looked at me and said, but surely if it's on the App Store, it's regulated. And that was the level of our chief clinical information officers. But that's just an example. I mean, people trust software. And even when because I teach professional issues, and even when I say to the students, you know, like, you have to realize that when you develop software, people are going to totally trust this. They kind of look a little bit in shock, but it's really, really important that they realize the level of trust that people have in their work. And it's shocking at a society level, kind of following what you were saying, what people believe in. Just because it's software, it works. Okay, sorry. So just for the people online, Brad has just said that if it's on TV, it's got to be true that people believe that. Yeah. So it's frightening, and that is a worry.
I read it on the internet. This answer you get from students, you know.
I'll just quickly share what Monica and Ita were saying. An incident that happened with a student yesterday.
Yeah.
We had a problem-solving exam-ish, and he solved it wrong. And it said, it's my problem because ChatGPT told him how to solve that problem in a certain way. And then I said, but you see, like, the problem says this, but ChatGPT didn't really get that. But he said, but that's not ChatGPT's problem. That's your problem because you have this ambiguous statement in your problem. So I agree, it's people, so I call it people are stupid. They will believe anything. It's our job as professionals to teach them what to trust and what not to trust and where to draw the boundary. But I do a lot of requirements engineering research. I see a lot of value of something like ChatGPT in requirements engineering, for instance, and you mentioned that as well. But they're also based on the experiments we've done. It produces good results with people who have more experience as a requirements engineer, like myself. I've worked in industry as a requirements engineer for several years, as compared to someone who doesn't know much. But it's really scary part is even these novices have real, very strong beliefs in whatever they're producing based on their interactions with ChatGPT.
Yeah. We're all going to sleep well tonight.
I would just challenge this. You say there is no model behind things like ChatGPT. There is actually a model. Question is, how complete is it? But the model is, of course, that the way that thought emerges is through a neuron activity and the networks and so on, which, by the way, is not necessarily a clear thing because we don't know how we go from that level to the next one. But there is a model there. And then there is this faith in something called emergence. So somehow if you put these things together, now again, emergence is not defined. You know, there's whole institutes that deal with this concept of emergence, whose nobody has defined, right? But they somehow think that if I put enough of this stuff.
There's schools of theology, you know, so.
But there is that model. The model is that, you know, this is a neural network and that's how we see it inside our brains. And somehow that will, as you said, you know, if we build enough of them, we're going to end up with it's called understanding.
It's a model. It's a model in that sense, but not in the sense I'm using it here. I'm using it a model as an explanatory, an abstract description of an existing phenomenon. And these are models in the sense that the neural network is the so-called brain model, and the learning is the training of the neural network. And you know, both of those are hypotheses about humans, which I think our little larva is going to disprove. Probably, it's probably going to find out that there are quite clever little loops in there that don't exist in neural networks. But that's for the future.
Again, if we go back to David Parnas, he said, you know, how can we talk about artificial intelligence when we don't even have a definition of what is intelligence?
Yes. Okay, we probably should stop because we've run over time.
Thank you very much, by the way.
Thank you all. Thank you for coming, and I hope you enjoyed it. Yeah.